A moment, подожди сейчас. Okay, first a little preamble. Today we are having a seminar on a project called Communicator by Fedor Bukreev here. The project was started last summer as a part of JetBrains research internship. And the idea is that we need a way to communicate between different scientific, at first, applications using passing not only the data but functions as well. And Fedor today presents the result of his bachelor work done in the last year. As always, a little addition is that the project is partially funded by the JetBrains Research Foundation. So, Fedor, please begin.
Yes. Hello, everyone. So I'm Fedor Bukreev, and I'll be giving a talk today on polyglot communication with high-order functions. So at first, I'll repeat and maybe say something additional about the aim of this project. So this project is for communication between different systems, and systems might be different languages or different computers. And we wanted it to be universal on all the different platforms and easy to use, even for people who are not primarily programmers. So let's begin, dive into this project. Here's a map of the entire project. So we can see there is a division between a browser and non-browser platforms. This is because browser does not support Unix sockets. So and this is our primary way to communicate between the systems. And today I'll be talking about the left part of the slide, which is ZimQ world. So what is ZimQ? ZimQ is the engine behind our project. It is a library that provides some high-level abstractions above Unix sockets and Unix channels. It also works on Windows, as sockets are supported there. So we have two main sub-projects in this project. We have pure Java virtual machine realization of all our systems and native in C++. And this native variant is supported by C API, which can be used by all kinds of systems. And for now, we have an example in Python. So now I'd like to demonstrate a very simple example. However, this example utilizes almost every aspect of our systems. We will be calling a Python function from Kotlin. So let's see the code. Here is our. Can you see the code? Is it okay?
Yes, it's more or less readable, but it is better to turn on the presentation mode because it won't be easily readable in recording.
Okay.
Appearance, presentation mode. Enter presentation mode. The topmost appearance.
Oh, yes.
And the topmost, yes.
Okay.
Okay.
So here's our Kotlin code. As you see, it's just 17 lines of code, including all imports and spaces and everything. So what's happening here? We declare that there is some function f that can take an integer as an argument and returns another integer as its result. Then we tell our library that this function is located on this address. So we're using thenq, as I said, and address is simple IP plus port, and in this case, we're using localhost. So what we can then do, we declare a client that our library provides, and all they left to do is to call our function. So we say just call, and this is an argument, and we get a result. So let's start a Python server, and so how do I? Okay, let's start the Python server. Let's start this function. How do I exit the presentation mode?
Alt plus you can exit the presentation. But what do you want to do?
I want to close the presentation mode, so part of my screen will be dedicated to Python.
Okay, Alt and or Shift and search everywhere, exit presentation.
Oh, I see. I found it. Okay, this is fine. Oh no, I launched code. I didn't launch the server. So, as you can see, I launched the Kotlin code that asks for function computation before the Python server. However, it still worked, even though the server started after this code was compiled and run. So the results.
Could you repeat what happened here?
Yes, what happened here? Yes. So a little disclaimer: we'll go and look in detail what happens behind the back, under the hood. But for now, I'll paraphrase it. So this code called a function f on this address, and the server was not started. So it just waited for it, synchron. And when the server has started, I missed again. So yes, we can see that server got a request to compute the function. And the function was a Python lambda here. So it's x squared plus 1, and this argument of 10, it's exactly 101. So let's talk in detail about what happened here. But at first, I'll mention that, as you can see, the code is fairly simple, and there is not a lot of it. That was one of our goals. So let's talk from the Python side, that is the server.
Maybe first it is better to clarify what was the aim of this example. You define as a server, a specification on the client side. Then you send request for the client to compute the function with a given value, and then you raise the server which computed the function, and it was the single time request, not the client closed after the first.
Yes, the client closed and the server is still running. Yes, there might be maybe multiple clients, and one client may interact with multiple servers. Okay, let's talk about this part in red. How does this work? So Python uses just bindings provided by Yaroslav Kostovalov to call the C++ code. And what's the reason C++ code? So you can see here several parts. There is communication protocol. It is a way how programs communicate with each other over 0MQ. There is a serialization protocol. It's so as we send the arguments and results of the function, we should know how to encode and decode them. That's why we have to declare that function, the encoded code that it takes integer as an argument and returns an integer as an argument. And for this, our library provides implementation for some basic types like integers, floats, strings, simple lists that are then transformed into the appropriate language primitive. For example, in C++ it is vector. In Kotlin it is list array, I believe. And there is a way to declare user-defined types that could be transferred. And there is a server part of the project and the client part. Let's talk about the server. So here we can see code in Python. It's just what really happens here is just we tell the library to create a server at a given address. And then we say that, yes, there is a function with this name. We want you to be able to compute. So then Python goes to C API that translates that functions to the C++ project. And then there is a server in C++ that listens to 0MQ sockets, parses the requests, computes the function, returns the result, thinks about exceptions, returns correct response if the function is not supported, and so on. This is the core function, the server that processes the correct request. Yes, here on the left of the slide, you can see basically a layout of the project. The server, when started, give you the ability to register functions, unregister functions, and starts the worker that under the hood starts a new thread in which does all of this. We can talk about the client part now. So this is a bit different. Our library provides, we have an abstraction called transport, and this is payload function. Payload function is basically a function that takes arbitrary amount of bytes and returns arbitrary amount of bytes. And under the hood, we transform any given user function into the payload function by encoding its arguments and encoding results and arguments. So this is all done automatically. And transport gives the ability to make a request to a given address to compute a function with given. So it's just a class with one function with arguments of address, name, and argument that returns bytes that we then automatically decode the function result. Yes, now I think it's a good time to talk about. So I told you that we had several threads, and so as soon as you have several threads, you have to think about multi-threading and synchronization and safety. So in the C++ part of the project, I decided to make an experiment and try 0MQ provided multi-threaded model. So here, what they say in the official documentation, to throw away all we know and just pour gasoline and burn it. Let's now see how they think it should be done. So all operations between threads are conducted via sockets provided by CRMQ. So there is only one thread-safe object in the code. It's the RMQ context. And so transport created transports created for each individual thread are not thread safe. So they have to communicate with some other class that consolidates all the requests, redirects it to the outside world, and returns it back and distributes answers accordingly. Yes. And if you're interested in any part of the code, we can go and dissect it as deeply as you like. So now, at the beginning, I talked about higher order functions. What are higher order functions? These are functions that take as an argument or return another function. So how can we do this? Here's an example picture of the process, but I have a working code. I suggest you look at that first.
This picture, I think we should stay at it for a moment because it should be placed at the start of your talk, since you will be defending your thesis soon, because otherwise it's not clear why the whole tool is needed. Here is an important part which separates the project Fedor was working on from typical remote procedure calls. Because in remote procedure calls, you usually have two layers, not three, like here. You have this program and tool or whatever, which sends the request and receives the response. Here, what is quite important is that you can send a request containing the function. Yes. And what is importantly, there is different way to send function. Some languages, for example, or frameworks like Erlang, they allow to send serialized code. This is not the case here, which is important because you not only send the pure function in the way of serialized code, you send a handler for a function, and the function is not necessarily pure. It, for example, could have access to data, internal data of your program, and internal state of your program, like caches. It is very important. It allows to do things which is impossible to do otherwise. And I do not know any analogs to this work. And I think it should be placed at the beginning of your talk and your presentation for a bachelor diploma. And this is a rather important point. Okay.
Yes, I just thought that in this seminar, I'd start with more simpler examples and then move to the...
Otherwise, people do not understand what I'm talking about and why go to such complicated things to do such simple things. They are always already solved a long time ago. Okay, let's continue. We will discuss it.
Okay, let's continue. We'll see the example of the hierarchy call. So let me close the idea. Both the server and the client now will be in C++, but this is not. There are no restrictions on this. It's just simply to look at the same language, in my opinion. So let's see. First, we can look at the server. So is the code readable?
Yeah, it's fine. I think it will be okay even in the recording.
Okay, so here's our C++ project. And now what is interesting here for us, this is an example server, this function called higher order. So as you can see, it takes another function as an argument and string. And all it does is take the function, take its argument, and apply the function to the argument and return the result. So here what we'll do is make this function to be computed on another server. We don't know anything about this function, but only its signature. So how we do this? How we do this? We okay, we can see, look at first at the simple function and then move to this complex one. So here's the same function as in Python that compares x squared plus 1. How we declare it here in C++, we just say its name and its type, and that's it. We can then pass this variable to the server and say, please compute this function if anyone requests. So with higher order function, it is a bit more complicated, but not really. So what happens here is the library automatically creates all necessary encoders and decoders for arguments and result values, and does this all automatically. But here we can do that as well. No, we actually can do that, but for the sake of clarity, we won't do that. So what is a remote function in our, from the point of view of our library? It's simply a reference to a real function somewhere else. So what do we need to compute this function? We need its name, its address, and we need to know how to encode its arguments and decode its arguments. So here we have a class called remote function. Yes. And to decode remote function, to use the remote function, we need a transport. We talked about a transport several slides ago. So yes, let's look at this thing. We call the same make library function method as before. We provide the name, we provide the function wrapped into a std function. So it would be able to be copied and not die if, for example, it was lambda and it went out of the scope. And then we provide a coder for the result and coder for the argument. So this is still pretty simple. We have to provide these coders as they don't have default constructors. Here, what is hierarch coder? It's a coder, and it is encodes two arguments for the function: a remote function and string. So string coder is still pretty simple. It's just it like take bytes and put it in the string and in reverse. And remote function coder needs one argument, is a transport. As I said, it needs transport, so the function could be actually called, and internally it will make a call to the remote server. So then we just start a server and list as many functions as we can. Also, we can do it more procedurally, type constructor.register function. That's no problem. Okay, let's start the server. As you can see, the server just starts and waits for user input, so it doesn't die instantly. Let's start the server and look at the client side. Right. So what does client want to do? The client wants to create its own function to work with a string and return some integer, but for some reason it can't apply this function itself, so it asks the server to do it. So what do we do here? We create transport. We state the address of the remote function, and then we create our local function to work with the string. Here it's a lambda. It can take, as Alexander said, capture the state of the program. So if we had some integer here that was inputted by the user, we could use it here, for example. That's not a problem. So what we should do next in the most clear way, we create a local address of this function. We create our own small server with only this one function. The names should not match. They can match and they can not match. It doesn't matter. Yes, and we start the server. Now, we want to call the remote function on the server we started several minutes ago. So what do? We create a reference to the function with our remote function class. What it does, it takes our address, which is just IP and port, the name of the function at our local server, and transport to be able to communicate. So we can just call it with a parenthesis operator. And we create real remote function that will apply our local function to the string we provide. We provide a name, exactly the same as the server knows this function. We provide a transport again and caller. Now, then we listen for user input and just call with simple parenthesis operator the remote function. Let me demonstrate. I'll remove this. So this code will be exactly the same as compiled one. No. So let's input some string like we have, yes, and here's the result is 3. It is, yes, here the result is 3. So let's look at what happened on the server and the client on the output side. So the server got request. Then what happened is it gave the remote function to the higher order function, and it called the parenthesis operator. And internally, they started a whole new process of this back and forth going. So here is multiple applications of a simple of a lambda, but we for now have only one. So yes, and now starting the return call. the server connects to the client's functional server and make request, get answer, and so on. So the client connects to the connects to the remote server with port 7777. Then it makes requests. Now the server makes its call, and finally we get the result that the length of the string was 3. Now, if we launch this again and, for example, get the result 4, doesn't change it. Yes. No, something has changed as expected. So here we can see that in the first round, there was this line connecting to the remote functional server on endpoint localhost 6666. But we don't get the second time. This is because we cache all the connections and don't perform this handshake and everything again. As you saw in our first example, here with 0MQ, we don't need the server to be running all the time. The client can deal with the server going out and popping up again.
Okay, the collection is maybe a little bit too detailed for this talk.
Okay.
So it could be discussed. It's too deep, I can say. Do you have anything else to add here?
So if anyone wants, I can talk about Kotlin, but basically the architecture there is really similar. However, it uses more conventional approach to multiprocessing. There's stately, but no 0MQ style multithreading.
Okay, you can show the results probably. If there are questions, we can discuss. I mean, you already showed the Kotlin code, and multiprocessing in Kotlin is pretty simple in this regard. Okay, why you're at it? Maybe there are any questions from people already.
Yes. If there are any questions, I'd be happy to answer them.
I think why people are thinking about questions, I think the work is very interesting, but it of course requires better documentation and better explanation, because right now it's hard to understand why it is done like it is done without first spending a lot of time thinking about it. And of course, when it is finished, in my opinion, it could revolutionize some things. For example, the task from which we started like 2 years ago, it was we've been working with this team from Munich, but Bayesian Analysis Toolkit team, and they are doing Monte Carlo sampler in Julia language. And for example, we have our data in Java or Kotlin or even C++. C++ is a separate problem, for example, when you work with a root ecosystem. And the idea was, why do we have to rewrite our code in a different language when we can call the functions remotely? But we not only to have to call functions, but we also want to pass functions, for example, likelihood function. And I think this project allows us to solve this problem. And what was done by Fedor and other people from this...
Yaroslav Postovalov and Yegor Zaitsev.
Yes, Yegor Zaitsev and Yaroslav Postovalov. It is very important. And I think you just need to finalize it, write a correct documentation, and present it correctly.
Yes, documentation is in progress. There is a docs again with not much, but some handwritten explanation, and there is Docker for Kotlin.
Yeah, I mean not only the code documentation, but also the motivational documentation.
Yes.
You have nice schemes here. Now we need to put it all together and prepare.
Sorry, maybe I have like a small technical question. There are many, I mean, there are a few different drivers for ZeroMQ in C, C++, and Java. And which ones you've chosen, and why did you make that choice? If you can explain.
Yes. Okay. So for the original plan was to use Kotlin Common for everything and to reduce a lot of code. So, but it failed, and for now we use GRenQ, which is pure JVM implementation for Kotlin. So it's more portable than bundling our code with some shared objects from C. For C++, the NQ PP is used, but it's basically a sync wrapper around libsynq. And for browser, it is still in works, and for now, we can't use ZeroMQ there, so we use RSocket, and we use RSocket Kotlin.
As far as I remember, for Kotlin Common approach, there was a problem with the parallel C++ code in ZeroMQ C++. Am I correct?
No. There is a problem with native Kotlin native header generation. There is bug in header generation for function types, so we couldn't provide correct API and resource it to use in C++.
I see. I'm not sure. Have you opened an issue about it?
Yes, Yaroslav opened an issue.
Okay, it's very nice. All right. As I said, I think you still need to put an effort to make a more compact and concise presentation about this project for your bachelor diploma and for presentation on conferences. But otherwise, I think that you've done a great work last year. It was very interesting and very promising project.
Thank you.
Okay.
As any other questions?
Okay, I wanted to ask if there is some discovery mechanism. So how do I know which functions by which servers are currently provided? Or is it something that you don't need to have for some reason?
Yes, about that. So, Igor Zaitsev started to work on something like that, but for now it's not our priority. And this library for now expects you to just know the address and name of the function. But it is possible to add this functionality to the library in the future.
Basically, there is, because right now on the server side, I mean the function server side, there is a registry on functions, and the idea was that you just request, please, function server, tell me what functions do you provide, and I think it was even implemented.
Yes. It is a part of the protocol, but you still need to know the address of the server.
Yes, of course. You need to know the address, but it tells you what functions are there and how to query them.
Okay, this should be enough, I think. That's what I was asking.
Yeah.
Oh, okay.
Thanks. And maybe one more question, like ZeroMQ, I think, if I recall correctly, it allows you to communicate, to send a message, for example, to multiple hosts at the same time. So are you doing this in some way?
Let me think.
No. For now, we do not. I do not think we use your routing protocol, and I'm not sure that we need it. I can't right now. I can't imagine the scenario where we could use it.
I mean, ZeroMQ sockets are useful for used in our project for listening for different other multiple different other sockets. That is extremely helpful.
Actually, there is one use case, because this project could be used not only for the remote call, but also by horizontal scaling of function computation. So if you, for example, have some kind of function which is very time-consuming to compute, then you actually could scale this function server. So the several different function servers which compute the same function, and the ZeroMQ routing then could be used to some kind of balance loading.
Yes, but for now it is not yet implemented.
Okay, that sounds very interesting. Thank you.
Thank you for
This
the question.
project, yes. So the final remark is that this project is also somehow connected to another project we've done last summer during internship. It's called Subcontractor, and the idea of this project is to propagate such requests, the similar requests like in this work, to a different server. So the idea is that you call, for example, a function server, and the function server can delegate its work to another server. This way.
So this is actually possible to do right now, as you saw that the remote function class is just a reference, a link to the function. So if in our higher order example we wouldn't create our own constructor, we could say that, okay, but we know that there is another functional server and want it to compute the string processing function. We could say that please remote server compute this function, and for its functional argument go to another functional server. This is possible.
Yes, it allows to create a heterogeneous hierarchical computational system. As I said, it was started last summer, but it was on hold since then because right now we do not have manpower to develop it, but the idea is there. Yes. Okay, then I do not see any questions right now, and we will finish for today. At least I will turn off the recording.